All right. Hello. So let's start maybe, right? Okay, so my name is here. My real name is a little bit longer, but no one is calling me like that, and everyone knows me here for a long time like this name. So I'm Maryniuk. I'm PhD at eSolutions in Germany. We are doing cars. So today I would like to talk about, I slightly changed the title here because I was looking and thinking about this presentation a couple months before I came here, so it evolved at some point. But it's like configuration management, which seems like right now I hear more and more demand of not just doing configuration management, but also checking what happened, right? And so let's start. Please work. Yes. So let me introduce you first myself. So I was doing before and what I'm doing now. So I'm doing automotive systems of observability at the moment. Then I was also working with previous also automotive company. We made embedded Linux, and I'm specializing in Linux distributions and tools to them to create them and this kind of stuff. Then I was doing safe Linux for automotive, again, boring stuff. And then I do many tools in Rust for that. In the past, I did configuration management from Sol to Unis as a manager, and a long time ago with Pablo sitting there, we were presenting these things together on the stage. Now we are, unfortunately, separated in sweet memory of Salt. So today I would like to talk about some little hybrid solution that emerged from specific problems we hit today with the devices which we work with, and we need to solve configuration management and understand why they fail after that or before that or during that. And so it's like automation and infrastructure management with accident and root cause analysis, so basically a hybrid solution. Now note, it's early working prototype. So it's like working in progress, you know, and I am not today selling you, please use that, but I am more like, would like to hear what you think about it. So, aren't we sold about yet this configuration management, right? And we have a lot of tools there. Why another one coming? And why is it? I mean, why would you write today something like that? So I would say first this. It kind of seems wrong that what meant to fix the system is part of the system itself. You see, I am in this kind of business already more than 25 years. And I remember when the CF engine born, so we had philosophy, at the time it was just shell script. We had the philosophy that there is a system, and I take my tool, and I go to that system, I fix the system, I go away from that system. So I'm not a part of the system, right? But where we are now today, it's like I was packaging Python stack for Salt for maintaining that, and then we have distribution here, there, and then build this for that because it doesn't work. If you deploy that, wrong Python, fail, and so on. I mean, in order to check the system, fix the system, I have to fix the fixer that fixed the fixed system. I mean, what is this, right? And that's something that I want to reset in this in this area. And additionally, I would like to build a community of I don't know what it is yet in the future. But you see, all the little devices, like my watch, like my mobile phone, like your little embedded devices, all that neglected, or let's say not existent in order to manage these things, right? So you have a standard servers, Kubernetes, and big things in rack for 250 kilos, these things, and you're managing that, it's fine. But how about a lot of little devices where nothing on them other than just Linux kernel, and that's it? How you manage these, right? And so I am trying to find out, can we also take that area, which is huge, apparently. And I've been in Germany, in Nuremberg, we have, we had Embedded World Messe, and there was a lot of various embedded devices. And the people from Norway, they came and introduced very interesting configuration management system only for embedded devices. But they required pretty much a lot of resources still. And that was the right track, but not that right implementation yet. So when I talk about those three monkeys, I used AI. I'm sorry, I'm guilty of that, and one is wrong, but whatever. So, configuration management systems, they are kind of like those three monkeys, and those configuration management systems we know today. Why? Because yes, please work-ish. So, they are write-only systems. You like writing things and waiting what will happen. They require dependencies, that's what I said, right? So in order to put the system on your target system, you are messing with those gems, with those pips, with those pearls, whatever it is. And the only one exception is MGMT from James. It's like more on the right track than anything else. And it usually requires some time. And I would be glad if this is just all those three monkeys. There's one more. These are grenades. So, you understand what I mean? Should I explain it? No? You're like, should it work? Oh, it did. Good. Yeah. And so, cars are very complex things. And Charity Majors, CTO from Honeycomb, she were telling a lot of good, nice things. Some of them, I absolutely don't agree with her, like absolutely not. When she says that Observability 2.0 is when you develop and debug on the production systems, not here. You're not flying on an airplane and debugging it. That's not happening. So you see, but the cars and airplanes, avionics, is a super complex systems, and they are, yes, they tend to be static. They are not that dynamic as your servers are, but still complex. And how do we do that, right? And I tried to wrap my head, so can I reuse Ansible? Can I reuse Salt? Can I reuse Chef? Can I reuse Puppet? No. And I took few slides from Charity, so if she's hearing that, that's credit to her, not to me. So, but that's very important. So when you have a cost of bug fixes, right, when you start at architecture, that's not that difficult to change that. Then coding gets a little bit more high cost, right? So integration, even more costly. Acceptance already been very costly. Now the problem is, if you go in production, they cost a lot. Not in automotive. In automotive is up to 11. You see, you have a firmware. You flash the firmware to the chip. You printed 40 millions of that. Then that you found bug. You don't fix that. You print new ones, right? But 40 millions are out, and that's how it costs. Like so. Speaking of the observability, the first definition of it was it's a measure of how well internal states of a system can be inferred from knowledge of its external output. The second, we become, with the time, more smarter, and we become more verbose. It's basically high cardinality, dimensionality, aggregations, UI, SLO, real-time, interactive, and so on, right? And then finally, we coined that out that observability has 3 pillars: metrics, logs, and traces. In which year you think was the first one, this one? Anyone?
1950 or 60 something. It was a mathematician, I think, or someone who...
No. Second?
I don't want to waste it.
No. How about the third one? Anyone? Yes. Yeah, that's like good. But today we have 2025. Are you ready for it? Ready?
Should we have like 7 more definitions?
No. Look for this one. So it's observability has 4 pillars, a lot of drama also. You look at those metrics and things starts, right? You look at your Grafana and it's like, what is this? Where it comes from? But still, so today's 2025. I would like to reshape that a little bit differently. Observability is the system's fundamental property of inferring internal state from external outputs. Repeat after me, fundamental property. So if you have a system, it has to have observability basically built in it. So you want it or not. And that's basically what we're promoting here. Please have observability with your system. But now how to manage that stuff, right? Let's go back to where I come from. So you are on the standard side, and I am on embedded, and that kind of looks like that. So you have whatever you want on your table. You can get any possible tool you want, install whatever Python you want, whatever other tool you want, and Bob's your uncle. That's my life on the other side. I have a kernel, I have libc, some, I have probably BusyBox with some few applets compiled, and I hope I have a writable directory in that somewhere. How you manage that system with Ansible? You don't. You just don't. And that's the problem. And I started to think, but I need configuration management system, right? And I have to somehow live with that. So what do I do? And so I wrote some stuff that works, by the way. And the goals, they're very simple. First, you have expectation, and you compare to the reality, if that matches. If that not, you take the reality and bring it to the expectation. That's very simple. And so, what is this about? It's a complex system examination, first of all, examination. Generate metrics, usually through the OpenTelemetry we do. And I thought, if you can read the system, and it's designed to read the system, you probably can write to the system and fix stuff, right? Occasionally. Though what exactly you want to write on the read-only system, I don't know, but sometimes you can, with some tweaks. Runs anything as a module, and let compare that. So first, what I want to say, sysimpact has no runtime. And it doesn't care what is your system, actually. On the other hand, all this pile of our known predecessors, they kind of require runtime. Then sysinspect basically does not need core utils, BusyBox, and everything else. So typical Ansible module or typical Salt module. I wrote myself half of the Salt in the past. So you take this module, and then you want to have a list of disks, run block ID. You want to know which kind of routes it is, write IP other and parse the output, and that's it, right? But you don't have none of these tools on the embedded systems. How do you know what your network is, right? So that's the problem. And requires other tool to be installed. Citizenspec doesn't. Designed to assert system integrity. So my first goal is to a lot of reading and understand what system is. While the others were usually designed to flush things like basically one way. So you can kind of mimic that with Salt. At least I can. I could if I could run the Python there. But again, would you run Python on that watch with SSH connection? I don't think so. You can do that. You can do that. But the problem is that if you talk about safety Linux, interpreted languages are forbidden. Sorry. And so, also, you know, Salt, for example, take the Salt, right? So you write a module that gives you a lot of information about your system, and you see that only half of the information came to you because they cutting it specifically, because they never designed the system to give you extensive output. They don't have pushback in mind at all. And for example, next is anything is a module. So I can run anything as a module, even binls if I need to. You can do this also with these guys, and I kind of did something else. I'll show you. And the last one, drum roll. It can run Ansible modules without installed Python. Take that. So again, summarizing it, the goal is to get it all. If it runs on embedded, it definitely will run on standard, so that's not the problem with it. It has different libcs. You have glibc, Mazel, Bionic, some other stuff, as long as it supports most of the standard stuff. For example, I tried this on NetBSD, it doesn't work, but whatever. It's 30 megabytes of one static binary for ARM. It's big, yeah, I know. It's bigger than Windows 3.11 in the past we had. Yes, I agree with that. But if you take any application today on your mobile, you know, it's like 200 megs, so it's like kind of okay. Yeah, and not GPL at all. GPL is, in my area, it's not a good license. So only Linux kernel has exception. Anything else, if it is GPL, no. And so now let's talk about it a little bit, how it looks like. So I have model description and I have hardware software. So think about model like a graph or like package dependencies, right? So package dependency is not a tree, but it's a graph that every many-to-many points to out, right? So you can describe your devices. And so we have a claims and states also, but states for now don't think about it. Claims. So basically I say, I think that on that box there is a network. So that's a claim to me, right? It's not what it is actually in the box, I don't know. But I claim that. And then on the hardware there are facts. So you send the claim to the action, and action is a module, goes to the hardware, and verifies is that true. It's kind of simple, right, to understand. And then you have a constraint at the end, which you construct the logic, how you want to verify that. And then module the action. It's up to you how to write, and constraint to you how to constrain the stuff. I try to be as possible as DSL less. So I still have DSL because it's inevitable, but I try to be very, very, very agnostic to that. So that's why I try to run this thing on different operating systems and stay away from the one particular one. And then you have an event manager, then it will send it all back. So basically, if claim said that action doesn't work, doesn't match the facts, so you start the constraint, and then it's wrong one, and then event says, okay, in this case, please apply some state. And you can repeat that in a loop, right? And so the the architecture is very much looks like Salt. If you familiar with Salt, so it looks like that one. So you have a command line interface, you have protocol talking to each other, API coming and not yet doing that. It has also file server with models and modules, and the one distinct thing, what I basically stole from Ansible, but they don't use it anyway, it's to dynamically manage the modules at binary level. So I was introducing that long time ago to Ansible community, but they kind of didn't get it, how to use the binary part of it. So they stay with Python. But because you need extra work for that, right? So you need to know which is target architecture, which Linux or Unix or something else, right? And which binary you ship there and then run. So it's like not well, nice. That's canonical, by the way. That happens. I don't know why that happened, but is there someone from Canonical here? No? I would like to make a bug report during the system. Oh, that's not good. Why this has happened to me right now, I don't know. So, while the ball is in air, so I can tell you, right? So let me try to. That broke. Seriously? What just happened to this machine? Okay. I'm so sorry for that. On Windows it doesn't happen, you know, so. I'm almost there. I have to only close a lot of stuff. And it's also, of course, destroyed my yuck. Okay, so I so wanted to show you that, so I'll try to. Okay, so let's go and start forward. Yes, good. So don't do it again. So yeah. And so automatically modules are synced to the specific client because client says what it needs. So it scans the model and says that not everything of the model needed for the client. So it says only part of it and says, okay, I need this model, and this model. Downloads from the server to the system. And as you can see, there is a traits. So it's equivalent to salt grains, if you know, something like those properties, you know, so you can select system by that. And there is a Python 3.12. But it's not that Python you think. It's completely implementation Python in Rust, which is built into the runtime with the whole standard library frozen in it. And so if I say there is no Python, of course there is Python because the script is written in Python, something need to interpret it. But you don't need to have the Python on the system. And it's surprisingly runs way faster than normal Python because it is hanging VM in the memory, you know, and then it doesn't need to spawn every time the same thing. So, and it also runs for me on Android, on Linux, on some BSDs, and I need QNX. I haven't seen Ansible on QNX. Maybe someone did. And x86, 64, and ARM. That's my targets right now. So that's where, especially on Android, where you have no SSH connection, so you have this ADB thing, and that's all you have. Sometimes you don't have even that, if Android is modified. So new things are coming. It's a eBPF. I want to fully integrate with that, and coming better telemetry events emission. So next stop will be DevConf in Brno, and if I will be presenting that, till the time I plan to have all that working, so it will be a little bit better. Let's a little bit under the hood, how it looks like. So claims, right? So you have YAML. Sorry for that. I thought TOML will be better, but I found I can abuse YAML a little bit better. So imagine you have a computer, right? So you see there is a button over there. It's red. It's black screen, nothing, right? And you have a state. So every system has a state. In car, for example, if you start the motor, you know, you'll hear and then big thing, right? And so if you hear, that's the first state, and when you hear big motor, that's the second state. If you hear both at the same time, go repair your car. So yeah, and that's just an example, right? So if you say, does this thing has network? How do you know? What defines the network? Do I have those IP addresses? Do I have those MAC addresses? Do I have those interfaces? Do I have those and those and those settings? Do I have that and that IP tables, that firewall rules, this addresses, this and so on, so on? This network is huge, right? So there are little small things that you have to check everywhere. So it's not just ping. Or like the guys before said, did we start the firewall? Yeah, we did start a firewall. Fine, but it's not for me. That's too little. So as you can see, when you start the computer, you see the Windows is working there, the green light is there, and cat is present, right? Because it's warm. And then you start working, actually, the cat gone, and you just work with the Windows, yeah? So actions is something. So that was claims, so basically entity. You describe basically, you have a box. It has Wi-Fi antenna. It has this cable, like that, like that, like that. It's basically like CMDB, right? And then you have action. So action, it binds to the specific entity, as you can see, and then to specific state even. So I am checking only powered state and nothing else, right? So it's like part of the model. And then there is a function claim, which will, in that context, on that entity, on that state, right? It will go with this path, buttons on off, but oops, what is this? Yeah, it will go buttons on off, and then it will run that module, and it's up to you how do you write that module. Module works with the sysinspect the same way as Ansible works, through the JSON, right? So you have just data, and you write whatever you want. So there is no DSL in it. That's because I don't know what you're checking, right, and how you're checking. Maybe you want to create all the checks in your module. Maybe you want to check in the DSL. So it's up to you. How do you do this? And then constraints at the end, they basically saying, again, they by ID to which action, then which entity it's binding, and then it says, basically, this is a path from your module. So buttons power will equals in this case, but I have a lot of operators. Equals, less than, and so on. There's like many of them. And so you can basically resolve this one, and this will return green, right? So, and then it checks if that correct. So that will tell you if that is good or not. And then it goes to the events. Events has a crazy thing, you know. Basically, there's the events, and then $ is to everything, like star, basically, right? And then you say action ID, entity ID, state, and error code. So error means means any error, just error, or you can specific code give which that, right? And then you say what handler and the handlers are built-ins. And then to each handler here, you have a specific configuration to that handler. They documented everything. You can add more handlers. And these handlers are doing what they need to do if that something happens, right? So you have the full circle about that. That just writes logs, they summarize dependencies, that sends alerts to knock and something else, right? Or you can group them together. Now is also action states. So they are not really different, and in this case, that's actually that Ansible call. So I wrote little Ansible bridge here, which Ansible is actually trimmed version installed on the client, just like a payload. And so it's programmatically calling that module, and then you can put typical Ansible stuff, right? So that's, again, binds to that claim, then this is state, and that's the module which takes real Ansible module, and then this is typical parameters you can pass to that. And that's basically it. Also, I have ugly conditions. That's a tribute for Justin, who today was bashing completely YAML and Jinja. To my defense, the whole year I was thought about that, and I didn't find anything better than this from pragmatic point of view. So if you have better suggestions, I'm open to it. Good part is that this is not Python. It's all implemented in Rust. So you not have real Python functions. So you cannot open Pandora box entirely, but it still looks like Jinja, right? So basically you say, it's typical, right? So you can, model is compiled on the client, and if trade says this is Ubuntu, then take file from elsewhere and so on. It's, I mean, self-explaining, right? So do you want to see the demo? Demo will be pretty much simple if the machine at all works. And I have no mouse here, of course. Where is the cursor at all? Hello? God. I still don't have, I don't have the mouse. There's the mouse, okay? It goes in this direction. So I will try to show you the demo, but please don't judge me, because like I said, this is work in progress. It's working-ish, you know, because it's I wrote this stuff in 2 months only. So, but it has enough already, something to do. So, does it work? Yes. Oh, how nice it is. So let's try to demo. Yuck. Okay, good. So since I absolutely don't see anything, okay. So here, for example, I start sysmaster. Did it start? Yes, it did. Here on another machine, which is, look at here, Python, command not found, one more time, command 3, there is no, trust me, RPM minus QR, it's open source, I believe, grab Python, nothing, right? So, sysminion, start. Fuck. Okay. And let me, on my machine, this is minion start. I don't see that well. Okay. So, and here, let's call it. I really don't see that. No, it's not correct one. I hope that will be so. So what I do, I forgot to mention that my models actually support full inheritance like object-oriented way. It's not just like solved merging two hashes together, but you can actually update things only where you want to update or add. So why is this? Because you have, for example, one car that is modeled with all possible features in it. And now you have variants of those cars. Or you have one server and you have variants of those servers. And you don't want to rewrite all the model because it's a very big one. So you want to only change what you change and that's it. And you can use the other one. So that's why I'm calling right now inherited, which has few lines only because everything else is coming from other. And then at the end is the star. So I am calling it, hopefully, and you see that's it. Here you see it called Ansible module. Didn't change anything because I already did it to check it works. So it just basically copied, etc. networks to TMP, etc. Copy is there, but it also failed, right? So you see errors on top, because it tries to see, to check if the during network is up, if the port is what I'm expecting, and the network interface, virtual, yeah, in this case VRBR one, is present, but not on this machine, therefore it crashed. But not crashed, but put there, right? And this one, in this case, basically did exactly the same thing because the model is the same, but this machine actually has that. And so it tells me what it is. So another thing what I wanted to show you, well, that's it. Then another thing what I want to show you says inspect, oh God. Shut down, please. So I'll kill all the minions. So what do we do here? Yes, I use Emacs. So I want to show you that's actual module, which is binary entirely. And I will call it somehow as it asks for, and I will show you its output, right? So if you just looking for, wait a second, you search here, sys inspect, no? Then modules, then sys, then net. So if you do the help, it has extensive help how to call it, what it can do, and basically examples, right? So let's call it. Zack, yeah. So it shows me all the information about my network. So it's basically the same as you would do address like this one. It's the same information, except I don't use that IP adder. I implemented all, it implements all by its own. So if you look, for example, Emacs, again, this one, so I'm typically wrong here. So, for example, I want to know the routing. Let's do it again, right? So that gives me like this. It's the same information here, right? So yeah, except that I fully implement myself because on the, like I said, on the small embedded machine, you don't have any tools at all. You even don't know which network it is, how to deal with that at all. You know? So that's the thing. Yeah. So that's what it is. And I want to say you as a goodbye message. So holding modern complex system models in your mind will bring you to a failure. Which means doesn't matter how your boss screams at you and wants to fire you or something, nothing will happen because the systems are super complex today. I remember back in times we were writing C code with some screensavers, you know, it was like 1995, something like that. And it was like, wow, a lot of stuff, you know, but if you compare that code to today, it's like day and night, right? So today code is like mind-blowingly big and you cannot have everything in your head. And so you have to follow the data. right? So if your system has observability as a property, right? So you follow the data and then you find the root cause why things are failing, because you cannot know everything. And that's, keep in mind that, and basically that's it. Because maintenance, extensioning, operation, refactoring, understanding, implementation are hardest part of software engineering. Writing code today is easy in compare. That's it, thank you. Questions?
Sure. Maybe just to try and understand like how it looks in your embedded world. What would you be mostly looking to monitor outside just well, to get observability on outside of just the config stuff or the Linux level stuff? What are the things you look most at the software you're deploying there? What are the biggest things you're looking at?
I'm not sure I understand the question, but...
You mentioned you plan to use this to monitor also not just Linux level configuration,
yes,
but at the application level, right?
Right.
So what would you be looking at in an embedded environment, and how would it differ from let's say, classic stuff in modern services?
Right, that's a very good question. Okay, so the question is basically how do we deploy, I'm repeat if I understood it all correctly. So what is the difference between, say, BSD or Linux, and how do you monitor and observe that, right? So how do you, which tools and means you add to that, right? So I plan to basically plant my sensors to the system I observe. So if it is eBPF and kernel supports that, I can inject that. But Android, for example, doesn't do it by default. So you have to recompile the entire kernel. But there are other means, like other polling and watching something, some typical stuff. You can do a trace if you want even, or something else. So basically it depends on the tools you can bring with yourself, or reuse what is on the machine. Sometimes in Android there are enough means to see what is going on. Sometimes applications are emitting telemetry on their own, and you're just capturing them and evaluating, and then you do the module, which looks if there is a spike somewhere at some point, right, which doesn't have to be there, or spike can be, but too often, you know, and then you can generate one more event that something is failing there. So it's like double watching, right? Yeah.
I've got a question, because in your architecture you have a client server set and everything connects to the master server. And what if the device is getting offline? How do you gather the data and, for example, sync it after some time?
Yeah, that's also on the table right now. At the moment, my use case that I have them online. And if they are offline, they are recording stuff if they can locally, and then they can send. So, but right now I don't have much that's done. So right now, for me, you see, the use case I have right now, it's a car. So there is no such thing as device gets offline, because if it does, you have a problem. So that's one of the things, if it goes offline, right, so it's already error. And the sysinspect can work the way like you bring your car to the shop where they repair it, and you plug the laptop to the car, and then it's like says which components are working, and they say that one is broken. So basically that's the case. And if the component does not respond, then it's broken in my case. But you have a very good point if the device are connected only through the Bluetooth, for example, right, or something like that. And you're not using it in the car, but you're reusing it elsewhere, like, for example, home watch or your garden looking if devices are around. And then, yes, that's a good point, and something needs to be done, but I accept pull request, by the way, if in case. Yes. Didn't you take it? Didn't you saw it, no? There was, before I had a QR code for that, which is somewhere here. No, still monkeys here. Doesn't work? Yeah. So that's his documentation. I'm getting older, I forget stuff, so every time I write the code, I immediately document it extensively. That's why you have so nice documentation. Thank you. Yeah. So, any more questions?
Well, from the perspective of other systems, for example, in Kubernetes, you have something like node exporter or node problem detector, that system that you, or application that you are able to compile to Golang and run on the different systems. And you can add extra checks for the system. I think that for the embedded devices, it's a bit different, but why didn't you try to create something that you just upload and keep it in there? I get the idea that you want to create rules and be able to apply them then, or get the info of the device dynamically, because it's going to be extended in the future.
Mm-hmm.
Okay.
Yeah. One reason why I also wrote it again, Sigi, my colleague, he always makes fun of me because I say it's written in Rust. The problem is, you see, I cannot use Go either, because Go in automotive will not run on safety domain because it is with garbage collector. And garbage collector in Go is shit. So no, it's unpredictable. So once, when they do something like Java has, you know, that predictable garbage collector, then we can use it. But I cannot use Go anything, unfortunately.
So it was not about Go or
Yeah.
language, more like they created a tool to
Yeah.
information about all the system. In all this, in install, they started to re-implement instead of using the libraries on the host, they just created everything in the code in Golang.
I will definitely look at that, but since I'm on embedded or small devices, the Kubernetes is not my strongest part. And I try kind of stay away from that ocean of problems, so yeah. Yeah. Some more questions? No. Okay. Oh, okay, one more.
Do you know something like the ESP and ESP devices?
Mm-hmm.
Could you try to run it on it?
No, not yet.
Okay.
But it's, like I said, it's really was a marathon development. I wrote all that stuff in just 2 months. And it's pretty much a lot of code to do. And I did it. And then now we are building the whole pipeline and all the test automation, all this kind of stuff. And so I will get back to that. And then, yeah, let's see how far I can go in the next couple of months. So, yeah. Yeah. Okay. Thank you.